So round all answers to the nearest hundredth. So we are taking everything to 2 decimal places. Calculate the mean, mode, and standard deviation for the following sample of scores. So on our calculator, to input data, we go to the table, click enter. Make sure you label the top as X before you type in your points. So 68, 72, 45, 100, 85, 98, 74, 48, 45. Once you have all your points typed in, your cursor should be at the bottom. You click Menu, Statistics, which is 4, and then 1 for Stat Calc, 1 for one variable statistics, and you click Enter. It asks you what your X list is, so we tell it it's X. And then enter again. So you have to remember that the mean is this little X with a line over it. So it's 70.56, 2 decimal places. For the mode, that's not on our calculator. The mode is what happens the most. So we look at these numbers and see what number occurs more than once. So let's see, 45 and 45. Does anybody else see any other duplicates? Nope. So your mode, or what occurs the most, is 45. Your standard deviation for a sample is this SX. So our SX is 21.4. And the reason why I'm not going to put a second decimal is because it's a 0, and it would not round up with that 1 afterwards. Okay, the great thing about these calculators is rather than having to do that all over again, you just go to the top of your data points and type in our new data points, 92, 77, 87, 68, 100, 46, 95, 98, 77, 68. Now make sure you don't have any other points listed below, otherwise you need to delete them. So the mean, the X with the line over it, is 80.8. The mode, or what occurs the most, we look at the data. So I have 68 twice, but I also have 77 twice. You can have more than one mode. So our mode is 68 and 77. The standard deviation, or the little SX, is 16.99. And the reason I'm using the SX and not the little sigma X is because it told me at the beginning it was of a sample, not a population. All right, calculate the mid-range, median, mean, and range for the following sample. So let's type in our new data points. 1, 2, 2, 4, 7, 12, 19, 22, and 24. And notice I have more data points, so I'm just going to delete that 68. So to find the mid-range, if you look at your definition paper, it'll tell you it's the high plus the low divided by 2. So my minimum is 1, my maximum is 24, and we divide it by 2. So 1 plus 24 is 25. And then if you don't know what 25 divided by 2 is, you can go back home and go to the little add, subtract, multiply, divide screen and type 25 divided by 2. So these calculators are weird. To get a decimal, you have to click Control Enter. And it'll tell you it's 12.5. To go back to my little table, you just go up here to the previous document, 1.1. And now we can get the median. The median is labeled median. And it is 7. The mean, which is the X with the line over it, is 10.33. Oh, it's the wrong way. And then for the range, you just take the high minus the low. So we're taking 24 minus 1, which is 23. Okay, we're doing it again. So we go and we type in our new data points. Y'all doing okay? You need me to slow down?
Yes.
Okay. Any questions on how I've gotten this data so far?
Is that 10.33?
Yes. And that's exactly what it said right here when I input my data. The X with the line over it is 10.33. 3 repeating, which is 1/3. Okay, so I'm going to go and type in my new data points. So we have 26, 33, 37, 38, 44, 45, 50. I'm going to delete these other data points. So to find the mid-range, we do the max plus the min divided by 2, or high plus low divided by 2. So we have 50 plus 26 divided by 2. If I go back up here, I already have my little calculate screen open, so I can do 50 plus 26 divided by 2 is 38. So my mid-range is 38. My median, go back up. Median is labeled median. And it says right there that it is 38. Bless you. The mean is 39. That's the X with the line over it. And remember, mean can also be that symbol right there. But on our new calculators, it looks like the X with the line over it. So mode, what occurs the most? Do y'all see any repeats at all? Nope. So you just put none. There is not a mode. Nothing occurs more than anything else. For the range, we take the max minus the min. So we're taking 50 minus 26, which is 24. Okay, we have more data. So 33, 47, 51, 64, 77, 79, 88, 90, 111, 112, 115, 132, 136. And it wants the 5-number summary. So it means it wants the min, the Q1, the median, the Q3, and the max. That's what the 5-number summary means. So I go back and I look. The min is 33. Q1 is 57.5. Median is 88. Q3 is 113.5. And the max is 136. To find your IQR, you take Q3 minus the Q1. So that means that we are taking 113.5 and subtracting 57.5. So I'm going to go to my calculate screen and I'm taking 113.5 minus 57.5. And it gives me 56. Now it wants us to make a stem and leaf plot for the following data. So this is where we separate it into a table with one number over here and then a number over here. So lots of times you'll see a key because these don't just have 2 digits, okay? They have 3 digits. So for my key, I'm going to say that 25 is going to equal 250. Because notice all of these numbers end in 0. So my lowest number is 250. Then I also have a 260, a 290. So we've done 250, 260, 290. Okay, then I have a 330, and I have a 350. My next start is a 4, and I've got a 450, a 480, and a 490. So what is the lowest value in the set? The smallest number we see is 250. And then it wants the median for the data. So you could type them into your calculator. I don't want to open up a new table because I've already calculated it over here. So I'm just going to go and change my data points. So we've got 480, 450, 350, 260, 290, 490, 330, and 250. I'm going to delete. If it's, you see these little lines on them, we just go back and click delete over the lines and the lines will go away. Okay. So you've got all of your new data points in. So the median is at 340. And I could have figured that out for my stem and leaf plot because there's 3 on this side, 3 on this side. Stem and leaf plots put them in order. So 3 and 3. And then there's 2 numbers in the middle, so it's going to have to be right between those. So it'd be 3 and then 40 would be right in between those. Yes. It's called median.
Oh, it's on there? Okay.
Yep. Median says median. Good question. Okay, so we've got some more data, so I just go back in, change my points. 150, 99, 289, 125, 114, 126, 140, 97, 124, 219, 300, 114, 84. And then it wants the mean. So the X with the line over it is 152 106.39. The median, it says median is 125. For mode, we have to look to see if any values occur the most. Mode is most. And I only see 114 repeating. Does anybody see anything else repeating? To find the mid-range, you take the high plus the low and divide it by 2. But really, guys, what am I doing if I add 2 numbers and divide by 2? Averaging them. You're averaging the high and the low number, exactly. So my max number is 300. My minimum number is 84. And then divide it by 2. So my second tab was my little calculate screen. So 300 plus 84. And then divide it by 2 is 192. The normal range, we just take the high minus the low. So 300 minus 84. 216. For the 5-number summary, you have to look back at your calculator, at your statistics, and they're asking for the min, the Q1, the median, Q3, and the max. So the min is 84, 106.5, 125, 184.5, and then 300. Uh, 184.5. For IQR, you take Q3 minus Q1. So we're taking 184.5 and subtracting the 106.5. And we get 78. Okay, then it wants the standard deviation. It's not telling us whether it's a population or a sample. So we're just going to do the SX like normal, so 71.21. Okay, so which statistic is most useful in this context? Which one of those blanks tells you the most information? The 5-number summary, I agree. Perfect. You good on the front? All right, the Astros 2017 season home run data is below. Draw a box plot and label the 5-number summary. So first I'm going to input all my data points. So 1, 24, 24, 13, 23, 18, 0, 19, 44, 3, 2, 12, 16, 14, 2, 4, 0, 5, 4, 2. All right, so for my 5-number summary, we've got 0, 2, 8.5, 18.5, and then 44. So I pretty much need to go from 0 to 10, 20, 30, 40, 50. And then I'll break it in half from there. So 5, 15, 25, 35, 45. Okay, so my first number is a dot at 0. My first line is at 2. And my next line is at 8.5. My next line is at 18.5. So there's my box. There's my whisker. And then my last dot is at 44. Do y'all think we have any outliers? Which one? 44 is probably an outlier. Do y'all remember how to calculate specifically if it is an outlier? Yes, you take the IQR times 1.5. So to take the IQR, you're taking Q3 minus Q1, and you multiply it by 1.5. So Q3, so 18.5. Minus the Q1 is 2, is 16.5. So that's how far away it can be from either your Q1 or your Q3. So my Q3 is at 18.5. So if we add the 16.5, it gets us to 35. So is 44 outside of that outlier? Yes, it is. That's how I got that. Because I took that 16.5, I added it to my Q3, and that gave me 35, and 44 is over that. So it is an outlier. Hey, do y'all remember what a cluster is? It's a lot of data points in one small area. It's easier to see with a dot plot. Remember how we had the dots on top of each other? Do y'all see a lot of our data points in a similar range? Yeah, probably over here, so maybe all the way from 0 to 5. And then gaps. Do we have a spot where we don't have a lot of values, where it jumps from one number all the way to another number? Okay, not excluding the outliers, but yeah. So outliers, we expect the gaps to be out between them. But what about in our data? So we've got all these low numbers going to 5, and then what's my next number? 12. So we've got a gap between 5 and 12. 7 numbers that would just be blank. Okay, so these questions you could calculate using your standard deviation curve. Because we don't have room for a standard deviation curve, we're just going to do it old school. So how many total data points did they give us? It's in your calculator. The N is 20. Okay, so out of 20, what percent of players should expect to hit 2 or less home runs? So how many hit 2 or less? 1, 2, 3, 4, 5, 6. Everybody see how I got those numbers? So 6 divided by 20. No. You can do Control Enter if you want the decimal. So 30%. What percent of players should expect to hit 18.5 to 44 home runs? 18.5, okay, so anything above that. The next one would be 19, 23, 24, 24, and 44.
18.5 is the third quarter, so anything above that's just 25%.
Correct. So 1, 2, 3, 4, 5. So it should be 5 out of 20. If you do it on your calculator, 5 divided by 20, 25%. And then what percent of players should expect to hit 8.5 or more? It should be 50% because 8.5 is that median, so half of them should be above that. If we were to old school calculate it, above 8.5 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 out of 20, which is, yes, 50%. So we already did 9 together on the warm-up. So 10, in a college government class, the average final exam score was 62 and a standard deviation of 4. So I'm going to create my bell curve. So my median, the average is 62. So this is at 62. Okay, a standard deviation of 4. So my next little curve is going to be 4 away, which would be at 66. And 4 away this side, which would be 58. So then the next part would be at 70 and 54. And then the next part would be at 74 and 50. So we know that this is 0.15% of the data, 2.35% of the data, 13.5, 34, 34, 13.5, 2.25, and then 0.15. All right, so what percent of students should expect to score 54? So 54 to 66. So you would add these 3 sections together. So 13.5 plus 34 plus 34. So 81.5% of students should score between a 54 and a 66. What percent of students should expect to score more than a 74? So greater than a 74 is just that 0.15 or 15%. No, 0.15, sorry. What am I doing? What percent of students should expect to score below a 58? So below a 58, you're adding these 3 sections together. So 13.5, 2.35, and 0.15. So 16%. If the professor uses the standard deviation to give letter grades where above 74 is an A, 70 to 74 is a B. 66 to 70 is a C. Oh, I missed it. These are D's, and the rest of them are failing. What percentage of students should expect to fail the course? So if that bottom half is failing, all of those should add up to 50%.